So good morning. Yeah, I am Jonathan Kaye. I look after product management and marketing at Ezurio. Today we're going to talk about Bluetooth channel sounding. Really, what I want to look at is about the multiple antenna support for that. So not single antenna, but multiple antenna support and what that means for accuracy of the system, how it works for the performance, and then really how does that benefit real-world applications. So, I am not an RF engineer. I am not a software engineer. I've worked in Bluetooth for 21 years now, but really in the field of product management. But I've worked with silicon vendors, our module teams, both hardware design and our antenna design capabilities. I've worked with our embedded software engineers through that time, and then ultimately I've worked with all of our end customers of how do they utilize these solutions in their products. So I will do my level best to make this as technical as my little brain can manage, but some of this will be relatively high level going into the mechanisms and concepts inside of channel sounding. What I really want to do is bridge that gap between the actual specification and implementation. What helps and improves performance in this system? 6 different sections that we'll go through. A high-level overview of channel sounding itself. Why is there a need for channel sounding? And why is an ecosystem approach, which is one of the important points I'm looking to drive home through this talk. We will then look at real-world testing, actual results of single versus dual antenna approach. We'll look at how we implemented that, what is the solution, both hardware, the algorithms, and mobile apps that will support your enablement and testing of that solution. So again, looking at that mobile phone ecosystem for channel sounding, what does it look like at the moment and where do we think it's going? A couple of slides just about where we're going to take this next with IMU integration and moving from 2 to 4 antenna systems, and then a few key takeaways at the end about the whole system and solution. So, Bluetooth channel sounding, pretty well promoted, marketed, awareness from the Bluetooth SIG has grown since this was launched in September 2024 as part of the Bluetooth Core version 6. Formerly, there was a lot of discussion and a lot of naming around this as high accuracy distance measurements, HADM, but please ignore that for now. It's just in case your memory goes back that far or you're in the working groups. It's now fully rebranded, I think for a better word, as channel sounding. In simple terms, it allows devices, Bluetooth devices, to understand how far apart they are, but with a level of accuracy that Bluetooth has not been able to convey before. And really introduces some new mechanisms, and we'll touch upon these: phase-based ranging, PBR, round trip time, RTT. It adds cryptographic detection inside of that to help improve the security and limit spoofing. And really what it's all about is multi-frequency measurement. The results, or what we're trying to achieve, is sub-meter accuracy, preferably in the tens of centimeters. Now again, we're not here to bash ultra-wideband or say that this is better than ultra-wideband for a granular location at a sub-10 centimeter level. It is not that currently. But really what we're looking to do is not estimate really the distance indirectly. We're looking to measure the radio channels themselves. So why the need for channel sounding? A lot of text on here that I simply won't read all the way through for your own time. But really, RSSI has been out for a long time. It's been utilized for quite a long time. It's relatively straightforward to implement, but it's only rough multi-meter level of accuracy. AOA, so angle of arrival, angle of detection, then came along after that and helped improve multiple aspects that RSSI itself couldn't do. It does require pretty complex antenna arrays. It's highly sensitive to multipath, which is something we'd like to be able to do something about. And ultimately, what has that evolution driven us to in channel sounding? You want the ubiquity of RSSI, but you want tens of centimeter levels of accuracy. So if you're a manufacturer of door locks, you make key fobs, you make industrial safety systems, knowing you're within meters isn't exactly super helpful. You need to be able to get into that tens of centimeters level that channel sounding is looking to be able to implement. So what is channel sounding? Again, a lot more text there for you to take away in your own time, but it's about precise distance measurement. And really, it utilizes a couple of core new mechanisms or concepts we'll talk about right down there at the bottom: phase-based measurement and round-trip time. So you'll hear the acronyms of PBR and RTT throughout this talk. And really, it's the combination of those two that will help get channel sounding to where it needs to be for that precise distance measurement. And we'll talk about these concepts of PBR and RTT in the next couple of slides. It can and will and does happily work on a single antenna, just to be clear. But what we will go through in the coming slides is the results of our testing and our partners' testing that shows how you can improve that accuracy with multiple antenna systems. But again, don't want to misconstrue the fact that a single antenna works perfectly great. No problem at all. Again, more detail here, and again, for you to go into that in your own time. But realistically, PBR measures phase shifts across multiple frequencies, and it's that multiple frequencies that is really the key part of this, or the key differentiation away from where AOA was. Because the wavelength is known, we can solve the distance around that. We then add RTT to that. So RTT measures actual time of flight, and it also has, what's the best way of putting this? Kind of a validation of the system through the cryptography of the packets itself, so that what you can get is, by combining them, you get resolution. You then add added security and a second way, or a cross-validation of the measurements and the information that you're getting back. What really matters to this whole system and how you can improve this is by adding multiple antennas, or certainly antenna optimization. And then how do you really scrub and process the data that's coming back from this? Because there's a lot of data that will be coming back through this system, and it's how do you make sense of that? This is my view, or certainly my company's view, of the different landscape. There is more than just this out there, but I figured this was a reasonable snapshot, single slide way of looking at how do people go about currently looking at distance ranging or distant measurement using lots of different technologies that are publicly available on the market, whether that be Wi-Fi, whether that be UWB in the cellular space. Obviously, we've had GNSS for a long time. But really, why should you be looking at Bluetooth in this environment? For me, it's about kind of four main things. Mass market availability. 9 billion plus Bluetooth chips are on the market out there. It's a well-known, well-utilized technology. Low power, pretty good accuracy. And again, it can't currently touch the accuracy at a granular level of UWB, but pretty good accuracy. Again, implementing multiple antennas, pretty good, robust indoor performance as well. And then ultimately, the thing that Bluetooth and Bluetooth Low Energy has always brought with it, a great low power budget to be able to drive against. In my opinion, it doesn't replace UWB. If you need sub 10 centimeters, at the moment, UWB is your go-to environment. But if you want low power, size, cost-sensitive devices, Bluetooth LE utilizing channel sounding is a very good approach for you and your end use and product. Such as wearables, logistics devices, we look at access control environments, lots of kind of everyday use cases that doesn't need specialized infrastructure or hardware to have true distance awareness for those devices. So again, you see this touted a lot in smart locks, safety devices, access control. It's approaching UWB level performance, but again, noting Bluetooth's ubiquitous advantage about cost, power consumption, and then scalable deployments out in the market. Now, from my standpoint, I work for a company called Ezurio. We're a module manufacturer. We have been for a very long time. We are very good at modules, utilizing Bluetooth Low Energy, and taking that out to market as a test house. What we are not is signal processing experts within inside our business. We don't particularly have a great volume of expertise in the Android 16 and mobile applications. So for us, channel sounding really lent heavily into how we needed an ecosystem to be able to drive this forward and take solutions to markets that customers can utilize now. Not theoretical systems, but actual kits, software, and mobile apps that will help customers test and deploy it in their actual environments. There is a lot of complex IQ data that comes across through the channel sounding process. But what the Bluetooth SIG didn't put into the core SIG specification for channel sounding is the actual algorithms that measure the distance itself, so getting that stable distance. And I'll touch upon that in my next slide. And so by combining multiple different partners together, you get the very best of the hardware, the antenna, the signal processing software expertise. And we partnered with a company called Metirionic, based here in Germany for that, and their Mars software stack, which I'll touch upon in a little bit too. So why the need for signal processing? And this is a quote straight off the Bluetooth SIG's website, that it's not my view, it's very clear, it's in the spec itself, that the actual distance measurement algorithm isn't part of that. That is for you to add your own value and interpretation to the data. The SIG defines how to collect the data, it doesn't define the actual distance or positioning. The performance and accuracy of the system is dependent on the signal processing, the antenna optimization, and then the multipath mitigation. And again, this is why we've approached channel sounding as quite a new emerging technology, utilizing a partner system and our ecosystem of providers to be able to deliver that. So, actual data, enough of the words around it. This is tested data. I have a picture on the next slide of the environment. It's a 12-meter chamber that we have, well, that Metirionic has, so 39 feet. I think I've got that right. Lots of concrete, lots of metal, not the greatest of RF environments. You've got the data plots on the left for the round trip time, then the phase-based ranging data, and then how that's been cleaned, for want of a better way, by adding the signal processing of the Metirionic Mars software over the top of it. And really it all comes down to the sigma, the difference of the symmetry and the spread, and really these are the core values to look at. So sub 1 meter of accuracy is what we're getting once we've taken all of that data set and cleaned it through the signal processing algorithms from Mars. So again, this is based on a Nordic NRF 54L15 chipset inside our module, really imaginatively called the BL54L15 module. And again, we've taken that single antenna at both ends, so a 1x1 configuration. So keep that number in mind, 1x1, 0.93 in terms of the meters, and then we look at that with a 2x2 configuration. So here is the antenna chamber that we've got. This kind of pulley system helps us take that down across the environment in this 12-meter track that we've got. And what happens when you apply 2x2, so dual antenna at both ends, is a doubling of the accuracy. So we're getting down to, this setup is giving us just short of 0.5 meters worth of accuracy, but again, dual antennas on both sides. So to my earlier point, single antenna works perfectly well, but you'll start seeing those significant improvements in the accuracy when you start applying a multiple antenna system to your initiator and reflectors. Just a quick look at the hardware of how we did that. We designed and developed our own dual antenna board. The purpose of this board is, could we plug it into our off-the-shelf available Nordic-based 54L15 kits? So you get a publicly available kit and something you can plug onto that so anyone can get up and running and testing. So the antennas, which is what you can see on the left-hand side of that screen, they're all fully tuned, fully matched antenna pairs for this board. So that complementary radiation pattern you can see in the bottom right hand enables the enhanced coverage between them. It's a simply put, you can't just throw two antennas on and expect to get optimized performance. There is work that needs to go around this. It connects into our boards via a standard pigtail MHF4 connector, but all of the RF switching, everything that you need for this is inside this little plug-in board. And then it has these, if anyone's used them, so micro E, they're clickboard connectors for stacking of different things. And we'll come back to that on some of the following slides when we start talking about IMUs. Not my field of expertise in terms of Android and mobile apps. We work with a US company called OneSlabs for their solutions around this, because channel sounding, as we talked about, is quite new. It's quite burgeoning. I know the spec came out in 2024, but a lot of things need to happen to get a full-blown global ecosystem of solutions that supports that, particularly in the mobile phone industry. So where can you go to test this on a mobile phone? At the moment, your only place to go is Android 16 on the Google Pixel 9 and Pixel 10 and 10a that's just come out. So that has full integration now for both initiator and reflector. It's in the full Android developer program. There is no support, as it stands at the moment, in the iOS or Apple ecosystem, and no stated or statements of support coming out from Apple. It's only my personal opinion, but it has to go that way. They will be moving in this direction. But as of today, if you're looking to test channel sounding on a mobile phone, you're limited to the hardware from Google and then Android 16 at the moment. A little bit more in here, and again, I won't touch upon all of these points. I just found it interesting that in Android 16, it's in their Ranging Manager API that also covers UWB and Wi-Fi, plus the RSSI that was originally there is where they've added in the channel sounding API for Android. It gives you access to the distance, the confidence levels, so again, that kind of traditional find me app of nearby, so kind of low, medium, high accuracy. What it doesn't give you access to, though, is actually the raw IQ data underneath. So everything else under that hub, under the hood, is not exposed to you through the Android apps. They can't see that. So really, it's a little abstracted from the raw radio data that we can see and that we showed you when we were talking about the Mars solution with the embedded dev kits. Again, a little bit more about all of the things that you can do and utilize within the Android developer, some links to where that is so you can have a little look at it in your own time. I would comment what we've seen in a lot of the testing, it's still very much beta. It's still very much in development from Android. We saw, for example, that the reflector mode worked in one beta and it didn't in the next, and then they fixed it again in the very next release. So still a very much a growing development environment, even at the Android API level. Ooh, thank you. So that's single antenna, dual antenna, channel sounding, and kind of what it is and what it's about. Really, though, what we've started looking at is moving beyond two antennas to adding additional antennas to the system and trying to test and validate and prove, does that again help improve that accuracy of the solution? AOA gave you the single frequency phase difference. Channel sounding gives you this wideband response, which is great. But what you would really like to be able to add on top of the distance measurement is angle estimation. Once you can get the pair of those, you have a significantly more valuable system. Now, the way to do that effectively that we found is more antennas or adding some elements of sensor fusion to your system to be able to interpret that data a little bit better. Ultimately, we found 4 antennas is kind of the sweet spot of, is this a realistic implementation scenario? You know, you can keep doubling and doubling and doubling, but who's going to put 8, 12, 16, 20 antennas in a system? You're back to the complex antenna arrays that limited some of the real growth of RSSI-based systems. To get that angle estimation, again, you need multiple antennas in different orientations to be able to do that. There is a link here, you can go and have a look at this, of just the impact and the performance of a 4-antenna system. Again, this has got nothing to do with Ezurio per se, this is done by our partner, Metirionic. But again, there's something out there that you can take a look at and see the measured impact of a 4-antenna system versus a 2. The next area we're looking at is integrating some form of sensor fusion into that development board. So we showed you the actual dual antenna board that we had before, and it had those micro bus, those micro E-click connectors. So you can take a dev board, add in the dual antenna array. You can then take an IMU click board, such as what you can see on here, add it on top of that. So you're getting all of the RF-based data for the distancing, and then you can add motion and orientation data from the IMU on top. And by fusing those all together, you get better stability, smoother measurements, and it delivers a much more consistent user experience. So again, if you're looking at moving or mobile devices, adding that additional level of data on top of the channel sounding will help improve that environment for you. Last couple of slides. So again, I can stand here and say this is all fantastic and the best thing since sliced bread. The best way to do and see that is to actually see it for yourselves. So in Hall 4, there's our partner Metirionic and ourselves, where we have demos for both 2x2 implementations, a 4-antenna array implementation, and the mobile phone support and assistance for that, so that you can have a look at that for yourself. And again, this isn't some future state. These development kits are available in the public channels, DigiKey Mauser. You can test and start playing with this yourself and really see what performance improvements can you get from adding a dual antenna system for your channel sounding product. And that was it, really, and not too much more to take away other than channel sounding is about true distance awareness. It came in Bluetooth version 6. It's relatively new. It is growing and evolving. The performance is based on the ecosystem itself, the radio, so the Bluetooth radio, the antennas, and then ultimately the signal processing that you do on top of that, the algorithms. And we've been able to prove, and we'll keep proving that our multiple antenna system really does improve the accuracy of the overall product. And come and have a look at it. Get started now with channel sounding whenever you like. And that was it. Thank you very much.